Hi there everyone, this is the second part of circle theorems, alright, so if you haven't looked at the first part, then please do so. You can look at after this, it doesn't really matter, but we're just looking at the 6 different circle theorems. So I've done 3 in this particular lesson and I've done 3 in another lesson, alright. So angles are subtended by the same arc, alright, so what we've currently got here is you've got 2 points on a circumference, so 2 points and 2 points, and then another 2 points. So basically 4 points on the circumference. And what you've got is this kind of bow tie looking shape, all right? None of it goes through the center or anything like that. We're not really bothered about that. But it's the idea of saying you've got 2 points, right? One goes over there, and then the other 2 points go over the pen. It doesn't really matter where these kind of points lie. So if I took those 2 red lines and moved them over here, if I took the 2 black points over here, nothing will change in terms of the rules of this. These 2 values over here will be the same, and these 2 at the bottom here will be the same. All right, so those 2 will be the same, and those 2 will be the same. All right, so if 2 angles are both created from the same point on the circumference, then both angles will be the same, essentially. All right, so you'll see that kind of bow tie looking shape. All right, so that one equals that one, and that equals. And again, just to mention, these are not going to the center, they're just going from one point on the circumference to another point on the circumference, and then this one's going to go to another point. All right, so I hope you can see that's 2 red lines and 2 black lines just going anywhere they like. Well, 2 x's will be the same, 2 y's will be the same. All right, so looking at this one, all right, so what we're looking at, find A and B. Well, these 2 are going to be the same, so A is going to be 52, and then these 2 are going to be the same. All right, there you go. So A is 52 and B is 36. All right, so looking at this one, certainly a little bit more awkward in terms of what I'm looking for. So there's bits and pieces of missing information here. So I'm trying to fill it in. So 47, so if I look at the bow tie thing, you can see it there, like that one there. All right, so that means this one and this one will be the same. This one and this one will be the same. But we're missing quite a bit of information to start with. So here we've got 2 straight lines, all right? And so if that's a straight line there, then this angle over here will be 180 take away 92, wouldn't it? All right, so that there's going to be 88. So there you go, 88 there. So either these 2, both these 2 over here is going to be 88, right, because angle's on a straight line. All right, so if that's 88, then that's 88. But it's gone for, oh yeah, it's going for that one first. So I said these 2 are going to be the same. So that one's going to be the same. So they're doing it this way around. All right, so 47 and 47, so this is a triangle, so 180 take away these 2 is going to leave you with that one there. All right, 45 degrees. All right, so quite an awful lot going on there. So not only, again, we're just looking at the rule which you just learned, which is this one, and the one at the top over here. This is now about applying angles on straight lines, so please look at that, another lesson on missing angles, and angles in triangles. So again, if you're not quite sure how to look at angles in triangles, but that's how we kind of got to this one. All right, so, and then that was the rule we're just going to come across. So you've got angles on straight lines, you've got the rule we just learnt, and then we've got angles in triangles. So starting to apply 3 or 4 different skill sets. All right, so please go back over some of those if you feel like you've got some gaps. All right, so let's look at the next one, tangents. Well, tangents, if you've looked at circle lesson, then a tangent is a line that just touches a circle at the edge. Looks a little bit like that. But the rule to this one is that a tangent forms a right angle with a radius. All right, so that's basically what we're here. So this is a radius which touches the same point as the tangent, and it forms a right angle. So the line from the center of a circle forms a right angle with a tangent. All right, the other rule is if you have 2 tangents here, so you've got a tangent going across here and a tangent going across here, well, BC and AC are exactly the same length. All right, so it's exactly the same length. So what it's actually forming is potentially some kind of shape which might involve either an isosceles triangle or similar triangles, essentially. All right, so AC and BC are both the same length. Okay. Right, so let's have a look here. So we've got all kind of things kind of going on here. So you've got a radius and a radius. And then, of course, you've got BD and AD, which we know are the same. All right, but it wants us to find X. Well, let's not overcomplicate this. 1, 2, 3, it's a 4-sided shape. So quadrilateral. The angles in the quadrilateral are to 360. So because I know that this one's 90 and this one is 90, well, 90 plus 90 plus 38, if I take that off 360, it's going to give me that one, isn't it? All right, so put those kind of in. So 360 take away the three angles that you've currently got is going to leave you with 142. So that's 142. All right. Right, so here we go. So find A. So I kind of mentioned it here about it kind of forming a specific shape, and I mentioned it when I was talking about this one. Well, these two are both the same length. It's going to form an isosceles triangle. All right, so if I put a little dash there and a little dash there, which represents it being isosceles, then these two angles over here would both be the same. So if I did 180 take away 44 and then halved it, I would get these two, and of course it's that 101. So AD equals AB. So 180 divided by, sorry, minus 44 divided by 2 is going to be 68. So that's going to be 68. So that'll be 68 and that'll be 68. All right. Right, finally, alternate segment theorem. All right. So looks like a windsurfer. That's how I kind of recognize it. But what you've got is a tangent, and then from that tangent, you've got essentially a triangle built from there. All right. So in terms of the wording, and again, this is the bit that I think people find a bit more confusing. If a triangle is formed inside, if a triangle is formed inside a circle, and one of its points is on the tangent, then the angle is equal to the alternate segment. All right. If that makes any sense at all. All right. So what we've got, and this is the bit you probably recognize, that this angle in here, pink, is the same as this one over here. All right. So that angle that's formed is alternate to that one up here, and then this one over here is alternate to that one over there. All right. So looking at this one here, so we've got a tangent and a triangle has been formed. All right. So what we're saying here is that this x is the same as this one, and then this one is the same as this one. All right. So x is 29 and y is 38. All right, so this is classed as the alternate segment theorem. All right, quite a popular one in exams, and they'll probably ask you the reason why. All right, so please look at maths-school.co.uk. There's a bunch of questions on all the different types of circle theorems for you to kind of practice on, and there's loads of kind of questions out there. All right, but of course you need to revisit this, then of course please do so. Please also look at the circle theorem proofs. All right, there are 6 of those circle theorem proofs to look through, and certainly with these days with the higher GCSE, the way it is that they like to test you on proofs of a variety of different things, and it's worthwhile looking at how I go about, or how you can go about putting proofs together based on information you've currently got. All right, well, thanks for listening.